In this video, we're going to talk about finding the greatest common factor. And specifically, we're going to talk about finding the greatest common factor of numerical expressions and variable expressions. So what is the greatest common factor? Simply put, the greatest common factor is the largest number that evenly divides a group of numbers. And sometimes, rather than saying greatest common factor, we'll just say GCF. So if I ask you to find the GCF of 8, 64, and 16, I'm asking you to find the largest number that evenly divides 8, 64, and 16. And when our numbers are small like this, it's pretty easy to see. If I'm looking for the biggest number that evenly divides 8, 64, and 16, that number obviously is 8. But we're not always this lucky. Right? We sometimes have to deal with larger numbers. So when there are larger numbers involved, are there any techniques that we can use to find the largest number that will evenly divide all of those numbers? And the answer is yes. So here's one way that we can find the GCF of a set of numbers. We can start by listing all of the factors of each of the individual numbers. Now remember, factors are just numbers that evenly divide a number. So let's start by listing all of the numbers that will evenly divide 8. All of the numbers that evenly divide 8 are 1, 2, 4, and 8. Now let's do the same thing for 64. All of the factors of 64 are 1, 2, 4, 8, 16, 32, and 64. And last, we'll do the same thing for 16. And of course, the factors of 16 are 1, 2, 4, 8, and 16. Now remember, we're looking for the greatest common factor of all three of these numbers. So to find the GCF, all we have to do is look through our list and see which number in these lists is the greatest that they have in common. So as we look through the factors of 8, 64, and 16, I notice that 8 is the largest factor that all of them have in common. So that means that the GCF of these three numbers is 8. 8's the biggest number that will evenly divide 8, 64, and 16. Now it's important to note here that the GCF of a set of numbers can never be larger than the smallest number. And that makes sense because in this case, our GCF was 8 and our smallest number was 8. Well, our GCF can't be a number bigger than 8 because any number bigger than 8 won't evenly divide 8. So just remember that the GCF of a set of numbers can never be larger than the smallest number. As I mentioned before, the numbers that we deal with, unfortunately, won't always be as small as the ones on the previous example. So what if we need to find the GCF of bigger numbers? There's another way that we can find the GCF. The first step to finding the GCF of larger numbers is to do a prime factorization of each of the numbers. So let's start by doing a prime factorization of 60. We know that 60 is 2 times 30, and 30 is 2 times 15, and 15 is 3 times 5. So there's the prime factorization of 60. It's 2 times 2 times 3 times 5. Now let's do the same thing for 252. The prime factorization for 252 is 2 times 2 times 3 times 3 times 7. Now we just want to find the factors that these two numbers have in common. To start with, they both have a factor of 2 in common. And then I notice that they have another factor of 2 in common. They also have a factor of 3 in common. The only factor left under 60 is 5, but there's not a factor of 5 in 252, so they don't have a 5 in common. So the only factors that they have in common are 2 times 2 times 3. So the GCF of these two numbers is 2 times 2 times 3, or 12. 12 is the biggest number that will evenly divide 60 and 252. We can find the GCF of variable expressions in pretty much the same way that we find the GCF of numerical expressions. Remember on the last example, to find the GCF of 60 and 252, we did a prime factorization of each of the numbers. And let's do that same thing with x to the third and x to the fifth. So let's write x to the third as x times x times x, and x to the fifth as x times x times x times x times x. Now, how many factors of x do these two expressions have in common? Well, they have one factor of x in common there, another factor of x in common there, and another factor of x in common there. So since these two expressions have 3 factors of x in common, the GCF is x times x times x, or x to the third. And that really makes sense because x to the third only has 3 factors of x that it can have in common with any other expression in x. So the most x's that x to the third and x to the fifth could have in common is 3. So that gives us a little hint when we're looking for the GCF of variable expressions. When we're looking for the GCF of variable expressions, all we have to do is always pick the expression with the lower exponent. So if I want to find the GCF between x to the third and x to the fifth, it will always be x to the third. If I want to find the GCF of y squared and y to the 10th, it'll be y squared. Always pick the lowest exponent. So let's look at this example. Find the GCF of x to the 9th, y squared, and x to the 5th, y cubed. Well, obviously both of these expressions have x's and y's in common. The question is, how many of each do they have in common? The first expression has 9 factors of x, and the second expression has 5 factors of x. That means that at most, these two expressions can have 5 factors of x in common. Choose the lowest exponent. We also see that these expressions have y's in common. The first one has 2 factors of y, and the second one has 3 factors of y. Choose the lowest exponent. So the GCF of these two expressions is x to the 5th, y squared. What about the example at the bottom? Find the GCF of a squared, b to the 6th, c to the 9th, and ab to the 4th. Well, just by taking a quick glance, we can see the first expression has factors of a, b, and c, and the second expression only has factors of a and b. Because the second expression doesn't have factors of c, then obviously we can't have factors of c in our greatest common factor because both expressions don't contain c's. So we know we're going to have a GCF containing a's and b's. The first expression contains 2 factors of a, and the second contains 1 factor. So choose the lowest exponent. The first expression contains 6 factors of b, and the second contains 4 factors of b. Choose the lowest exponent. So that means the GCF of these two expressions is a to the 1st, b to the 4th, and we don't need the 1 in the exponent's place. Let's find the GCF of these 3 expressions. 10x cubed y squared, 60x squared y, and 30xy squared. These expressions contain number coefficients and variables. So let's start by looking at the coefficients of each of these expressions. And let's find the GCF of the coefficients, 10, 60, and 30. Well, this one's pretty easy. We can kind of look at it and say, okay, what's the biggest number that will evenly divide 10, 60, and 30? Keep in mind that that number can't be bigger than the smallest of the numbers that were given. So the number can't be bigger than 10. So the question we ask ourselves, okay, will 10 evenly divide 10, 60, and 30? And of course it will. So the GCF of the coefficients is 10. Now let's look at the variable factors in each one of these expressions. The first one contains x's and y's. The second one contains x's and y's. And the third one contains x's and y's. So all three of them will have x's and y's in common. The question is, how many do all three of them have in common for the x's and for the y's? The first expression has 3 factors of x. The second one has 2 factors of x. And the last one only has 1 factor of x. Choose the lowest exponent. The first expression has 2 factors of y. The second expression has only 1 factor of y. And the last one has 2 factors of y. How many factors of y do all 3 of them have in common? Well, they can't have more than the lowest exponent. So choose the lowest exponent again. So the GCF of all 3 of these expressions is 10xy.